Okay, this lesson is on counting. There are 3 different ways we're going to learn how to count. One of them is using the fundamental principle of counting. Then we'll use permutations as another idea, and then unique permutations in certain specific situations of permutations. The first thing we're going to look at is when you're looking at outfits and what you could wear to school. Let's say you have 5 shirts, 7 pairs of pants, and 6 different hats that you wanted to wear in different combinations together to make an outfit. So the fundamental principle of counting works out like this. Each set of choices you're going to have to make on each different shirt, pants, and hat, coming from its own separate sample space, there are 3 of them here, you're going to multiply your choices together. So if I have 5 choices of shirts to pick from here, then I have 7 to choose from here, and then 6 to choose from here. If you simply just multiply your choices together, take your calculator out, 5 times 7 times 6, and you'll get 210. There are 210 different outfits that you could wear with those sets of clothes and hats. So, next thing, moving on. This fundamental principle of counting, again, looks at separate sample spaces. In that case, it was shirts, pants, and hats. In a license plate, you have digits. The first digit has options 0 through 9. You also have numbers 0 through 9 and numbers 0 through 9. So there are 3 different sets of digits, 0 through 9, that you get to pick from. So there are 3 separate sample spaces here, plus letters. Let's say you had letters of the alphabet, and you have 26 to choose from here, 26 to choose from here, and 26 to choose from here. So in other words, then you have 6 separate sample spaces, and if I multiply those choices together, I would get an answer that looks like this. 10 times 10 times 10 times 26 times 10 times 26 times 26, and I would get 17,576,000 different license plates. That'll cover you for a lot of cars in Minnesota if you had numbers first and letters after. But there's other combinations. You can have personalized license plates, and they have different kinds of orders of the letters being first and so on. What this shows, though, is that it's allowing you to have numbers repeating. If your numbers can't repeat, then you have to then have restrictions on things possibly, and you may have letters that don't repeat. Then the way you calculate this is a little bit different. If you can't repeat the numbers, you're going to say that I've placed one of my numbers down here. I don't know which one of the 10 I chose, but then I have 9 left to choose from here. And then if I chose 2 numbers already, then I only have 8 left to choose from that I could pick for that 3rd spot. And letters work the same way. If I couldn't repeat the letters, I would have 26 to choose from in the first one, but then I'd only have 25 left to choose from here, and then 24 left to choose from here. So as I multiply those together, I'll get a much smaller set of cars that I could have license plates for in Minnesota if I multiply my choices together. Again, 6 different sample spaces, that's what fundamental principle of counting is about, choosing from separate sample spaces. Now, what if we only had 1 sample space to choose from? That's where we're going to use the idea of permutations. Permutations means if we have 1 set of runners that are going to run a race, and they're all going to come in different places in the race. So if I have, in this case right here, how many choices of people could finish the first spot in the race? Well, that'd be 5. Then if that first person then runs across the finish line, then there's only 4 left that could finish in 2nd, 3 left that could finish in 3rd, then 2 left that could finish in 4th, and last of all, 1 that could finish in 5th. If I multiply those choices together, I get 120 different ways that the runners could finish a race. Hopefully you're noticing then a permutation is 1 sample space. Unlike the outfits, menu items, codes, and passwords, and license plates, those are going to be choose from different sample spaces, and that's what makes them a fundamental principle accounting type question. 1 sample space, and the order is important, how they finish, that's what we call a permutation. All right, moving on. Sometimes that calculation that we just made can be figured out a little bit easier. In that last one, we had 5 people choosing to pick for first place, 4 for second place, 3 for third, and so on, and you multiply your way down. There's a thing called factorials, this 5 exclamation point. That's another mathematical way of recognizing that when you see numbers counting all the way down to 1, a factorial can help summarize that calculation. On the calculator, if you press these buttons, 5 to make this 5 show up here, and then math, and look for the PRB option by using the right arrow, and then choose option number 4. Let me show you how that works. If I put in 5, that's the 5 I'm going to make for the part right here. Then I go math, left arrow is how I'm going to get here, but you can go to the right too. It just basically makes this selection thing go across the top of your screen until you select PRB for probability. And then you're going to choose the exclamation point, which is option 4. So 5 exclamation point is the exact same thing as 5 times 4 times 3 times 2 times 1, like we just calculated. So hopefully you're noticing that you can do these longer calculations a little simplified by using an exclamation point or what we call a factorial. Here's another example you could try. I wouldn't want to type all these digits out. I could simply just use 8 exclamation point. So if I were to go in here, 8, math, left arrow over to the PRB, and then option 4, There are 40,320 ways that 8 runners could finish a race, skiers, snowboarders, or 8 items that I want to put in a specific order and lay them all down. It could be letters, it could be anything. There are 40,320 ways to do that. So as you'll notice, the more options we have, or things we include in our calculations, the bigger the number of ways we can do it. Permutations, one set of numbers. How many different ways can you lay them all out? A factorial can help you make that a little bit easier to figure out. Next, we look at what are called unique permutations. Unique permutations are, just like we just figured out, there are 3 letters, so that means we have 3 options to put in the first spot. We have 2 options to put in the second spot, because if you lay one of these 3 letters down, and then you'll only have 1 left to put in the last spot. There are 6 different ways to lay these letters out. So if I want to see what that 6 different ways looks like, I could have MOM. I could also have MOM again if I reverse those 2 letters. I could also then put the O in the front and have OMM. And then I could reverse those 2 M's and get another OMM. And then I could take the last, or the O, and move to the last spot and say I have MMO. And then I could reverse those again and have MMO. Now the problem is, a unique permutation, these are not all unique. These are repeats, so we don't want this to happen twice. So I'm going to have, there's 1, there's 2, and then I'm not going to count that one, and then here's 3. There are only 3 unique ways to do this. Even though there were 6 different ways to rearrange the letters, there are only 3 unique ways to do that. And here's how we calculate a unique permutation. You take your total that you have, factorial. In this case we had 3 letters, so that means we had 3 factorial, and you divide it by the repeats factorial. In this case here, we only had 1 set of letters that repeated. We have 2 M's that repeat, so that makes 2 factorial. And then if you do that in your calculator, put it in as 3 factorial, so 3 math, left arrow 4, divided by 2 math, left arrow 4, you get the answer of 3. And that's exactly what we got in our picture as well. We have 3 unique ways to rearrange the letters MOM when doing this problem. The way you're going to get the correct answer next time, is to make sure you always divide out anything that repeats from your total, okay? Let's try another one here. Let's try the word puppy. Puppy has 5 letters, so we're used to doing this from before with erasers too. We got 5, we got 4, 3, 2, 1, which then equals 120 different ways. We've already done this calculation. It's also done with 5 factorial. So that means then if I want to take out if my total was 5 letters to pick from, unfortunately there are 3 letters that are repeats. I want to take those out so I don't count them more than once. I want to take my repeats out, so I would take out 3 factorial. So then I take my calculator out, and then you'd make this calculation just like this. You go 5 math, left arrow 4, divided by 3 math, left arrow 4, and you hit enter, and then I get 20. There are only 20 unique ways to rearrange the word puppy, so that's how you do those kind of calculations. Now, there is some special situations that you're going to run into. It could be objects, it could be yo-yos, it could be cars that are all the same color, it could be coins, it could be whatever it is. In this case, I have dots. Here I have 1, 2, 3, 4, 5, 6, 7, 8 dots, and of those 8 dots, some of them are repeat colors. So if I asked you how many different unique ways could you rearrange these dots into a specific order where the order is important, again, I have 1 sample space, which is what makes this a permutation. I could then say I have 8 dots, so 8 factorial, over, and then what you have to be very careful with your calculation when doing multiple repeats of letters, in this case, dots with colors here, you have to make sure you have parentheses here. So I have 3 purple that repeat, I have 2 green that repeat, and then I have 3 red that repeat. And then putting that in my calculator, it's as simple as this. 8 math, left arrow 4, and then I'm going to go divided by parentheses. The parentheses is key, because if you don't put the parentheses there, it won't divide the whole set. Then I got 3 math, left arrow 4, 2 math, left arrow 4, and then I got 3 math, left arrow 4. And then I've got the whole thing typed in like this, hit enter, and I got 560 ways to rearrange these dots in unique ways of doing so. So I have 560 ways to do this. Last of all, just to recap one more time, when we have counting going on, if there's separate sample spaces, it's fundamental principle of counting. If it's just 1 sample space and the order is important, then we lay them all out, we have permutations. If there's anything that's going to be unique, then we have to make sure we always divide out the total factorial by the number of things that repeat factorial. And again, if there's multiple objects, then you want to make sure you have parentheses around your denominator. Good luck, and hopefully this video helps.